Hello, hi, a very happy good evening. So this is Krishna Ma'am and we're going to talk about the story of life on earth, and that's biology. So thank you for joining my new beginning today. So we are going to talk about master endocrine gland, the part of chemical coordination and integration. So I hope you have understood yesterday's topic. So we have been talking about hypothalamus, we spoke about pineal gland, so we also spoke about thyroid gland. So it's a continuation today. So we are in the last topic of human physiology. So I hope you're enjoying it. So we're almost towards the end of one complete unit. So from Monday we'll be having Monday, Wednesday, Friday class 12 topics, and Tuesday, Thursday, Saturday class 11 topics. So today let's talk about the master endocrine gland. So what is the master endocrine gland? So that is the pituitary gland. So it's not only that we'll be talking about the pituitary gland, so we'll also finish off others accessory glands, so that we finish off this chapter quickly. So probably tomorrow we'll be done with this chapter. Hello Bhavya, yes, a very happy good evening. So thank you so much for joining my lecture today. So you didn't come for 2 days, but I hope you have watched my recorded lecture. So please don't forget to like, share and subscribe. Hello ma'am, a very happy good evening. So you're on time, so thank you so much for joining my lecture today. So please do like, share and subscribe. So yeah, so Bhavya says okay, fine. So I hope you guys are doing well. So please take care of your health, because in some places it's pretty cold, it's getting colder, and in some places it's still raining. So please stay safe so that you don't have to fall sick, and then once you fall sick you lose the entire proper routine. So please take care of your health. So that's very important. So everything else can wait, not your health. So please give utmost importance to your health. So eat things that are healthy, so don't eat a lot of junk. So I know junk foods are tempting, but yeah, so you can have them once in a week, not every day in a week. So it's really bad, because I can see students where I live, so I can see students always munching on the junk food center. So the junk food center is most crowded, not even the coaching institutes, but the junk food centers are very crowded, but that's really harmful. So please take care of your health, because you are going to be doctors tomorrow, so you should be knowing how to take care of yourself. So as a biology teacher, so I thought I should put a word to you. So avoid junk food. So you do not know how it affects. So what if it's half cooked? So it might lead to a lot of intestinal infections. So it might lead to, what if the water does not suit you? So please take care and stay safe. So be precarious so that you don't have to face any problem. Okay, some days my physics and bio classes clash, that's why I'm not able, you're not present last 2 days. That's absolutely fine, Bhavya. So as long as you are in sync with what I'm teaching and you have seen my lectures, I have no issues. But please do get in touch with the Telegram group, and please do ask me doubts, so that I know you are in track. So if you guys don't ask any doubts, which means you have not studied. So when in a paid batch we have a exclusive counter called as a doubt counter, so where we have 1 hour of doubt sessions. So students keep asking, the students keep shooting a lot of doubts, and we keep clearing them. So when you guys don't ask doubts, so it means you guys are not prepared. So please ask doubts, solve as many questions as possible. All right, okay, so let's move forward. So let's not waste much of today's time. So before we talk about master endocrine gland, so I would like to give you a reminder about the Pathfinder course. The course is already begun, guys, so please make it quick. So please join us. Yes, Bhavya, so thank you. So please join us. The course has begun from 15th of November, but still you get access to the recorded lectures. But don't delay any further, hurry up, come on quick. So this is the Pathfinder course, and you have the physics, chemistry, bio, everything in complete English language. So please join. So it'll be, we'll start with class 11, so we'll finish off the basics, then we'll go to class 12. So it's a complete package. So we'll teach you the entire syllabus for NEET exam, plus we have sheet discussions, plus you have unit tests, you have chapter tests, you have full syllabus tests. So please make the best use of it, so that when you are enrolled somewhere, when you follow the schedule there, so you have to follow something religiously, so you don't tend to get distracted. So make it quick, so please follow. So this is an online course, so you don't have to travel all the way to Kota to meet me, but we have Zoom sessions where I can have one-on-one sessions with you. I can clear the doubts, etc. So this entire package is for 35,000, but if you use the coupon code KR10, so you get 10% off. So you get an off of 3,500. So you just have to pay 31,500. So please hurry up. So we are starting with biological classification. So please join me there. All right. Okay. So that is all I want to tell you. So before we move forward with the master endocrine gland, so I would like to revise yesterday's portion, because yesterday also we were talking about a few glands and their hormones. So I want to give you an overlook of what we spoke yesterday. Fine. So let's move forward. So we were talking about what are endocrine glands. So endocrine glands are ductless glands, right? So endocrine glands are ductless glands, and their secretions are called as hormones. So now how did we define hormones? So hormones are non-nutrient chemicals and these hormones act as intracellular messengers. If you remember, so we had this term as well. So intercellular, so this is between two cells. So they act as intercellular messengers and they're always produced in trace amounts, right? So this is what we read about hormones. So this is how we started this chapter. So then we went on to talk about the human endocrine glands. So this human endocrine glands, so we had totally 9 glands and I listed them for you. So giving you a quick recap of what we spoke. So the first endocrine gland is hypothalamus. So next we have the pituitary gland. So number 3 we have the pineal gland. Number 4 we had the thyroid gland. So I'm going in order from the brain till the abdomen, from the anterior to the posterior part. So we have the thyroid. So then number 5 we have the parathyroid gland. And then number 6, so we have the adrenal gland. Sorry, we also have the thymus gland. So adrenal comes after thymus. So then we have the pancreas. And number 9 we have the gonads. So the gonads include the testes and the ovary. So these are the 9 human endocrine glands. So yesterday we spoke about hypothalamus, pineal and parathyroid gland. So today we're going to talk about the master endocrine gland, that is the pituitary gland, right? So now before we go, so let me quickly tell you the hormones of hypothalamus, pineal and parathyroid. So we were talking about we started off with hypothalamus. So we know where hypothalamus is present. So hypothalamus is present in the forebrain. So forebrain is also known as diencephalon. So the cells of the hypothalamus are known as the neurosecretory cells. So these neurosecretory cells produce 2 types of hormones. So one is stimulating hormone, which stimulates the production of other hormones, and the other type of hormones are inhibiting hormones, which inhibits the production of other type of hormones. Okay, so the stimulating hormone example we spoke is GnRH. So this is gonadotropin releasing hormone. So this acts on the master endocrine gland, that is the pituitary gland, and it asks the pituitary gland, or it stimulates the pituitary gland to synthesize gonadotropins. So the gonadotropins are your luteinizing hormone and your follicle stimulating hormone. So these are the 2 gonadotropins, and your GnRH stimulates the release of these hormones. So an example of inhibiting hormone is the somatostatin. Sorry, it is the somato. So this inhibits it acts on the pituitary gland to stop the production of the growth hormone. So this is how it inhibits a particular hormone. Alright, yes, clear? So this is our hypothalamus. So this is what we spoke about the hypothalamus yesterday, and hypothalamus and pituitary are very nearby each other, but we never touched upon pituitary gland yesterday, and today we are going to talk about the pituitary gland. So the next gland I would like to revise is the pineal gland. So the pineal gland is present on the dorsal region of the forebrain. It is present in the dorsal segment of the forebrain. Alright, so this pineal gland produces only one hormone, that is melatonin. but this melatonin has a lot of function. So the main function of melatonin is that it plays a role in the 24-hour cycle of the body. So it plays a role in metabolism. So it is also your sleep hormone. So it plays a role in pigmentation. So I told you about graying of hair yesterday. So it also plays a role in the menstrual cycle in the females. And at the end, it also plays a role in the defense mechanism. So these are the functions of your hormone, that is melatonin. Fine. So after pineal gland, so we also spoke about the parathyroid gland. So the parathyroid gland is present on the thyroid gland. So parathyroid gland. So we have two lobes. So this is one lobe of your thyroid gland and this is another lobe of your thyroid gland. On each of the thyroid gland, you have a pair of the parathyroid gland. So this is your parathyroid gland. So we have two pairs of parathyroid gland, or we have four parathyroid gland. So your parathyroid gland produces one hormone. So the name of the hormone is the parathyroid hormone. So it is in short known as the PTH. Okay, so this parathyroid hormone, it increases the blood calcium level. Your calcium is very important. So this increases the blood calcium level and it is also known as the hypercalcemic hormone because it increases the concentration of calcium. But from where does it get the calcium? From the bone, because the bone have calcium salts. Then next place is from the renal tubules, also it takes calcium. From the digestive food that we ate also you get calcium, because of course if you have milk it gives you a lot of proteins and calcium. So that is the reason, that is the regions where your parathyroid hormone can absorb calcium and help maintaining circulating blood calcium levels. So these are the things that we discussed in yesterday's lecture. Now moving to the master gland. So that is the master endocrine gland, that is hypothalamus. Okay, so so I had space to write pituitary, pineal and parathyroid, but I have finished it in one slide. I'm really sorry. Okay, so pituitary gland, so this is the master endocrine gland. So why it is called as the master endocrine gland is because a lot of other endocrine glands are stimulated by the pituitary hormones. So if another gland has to work, the signal comes from the pituitary. So you and I cannot stimulate the production of other hormones of other endocrine glands. Say for example, a person's thyroid hormone is less. That is pretty common, right? Now, if I have to stimulate the production of thyroid hormone, then giving a drug to stimulate the production of thyroid hormone, I will stimulate the thyroid hormone signal from the pituitary so that thyroid can produce hormones. So that is the reason your pituitary has this commendable name, the master endocrine gland. Okay, so we know your pituitary is very close to the hypothalamus. So we have the hypothalamus here and we have the pituitary. So the pituitary gland also has another name, that is hypophysis. Hypophysis. So this is the other name of your pituitary gland. So your pituitary gland is divided into two parts. One is anterior and one is posterior. So the anterior is the top portion and the posterior is the back portion. So the anterior part of the pituitary gland is known as adenohypophysis. So anterior A, adeno A. So the anterior part of the pituitary gland is adenohypophysis. So you know hypophysis is your pituitary gland. So the anterior portion is adenohypophysis, right? And the posterior portion is known as neurohypophysis. Clear? So this is the general introduction about pituitary. But your pituitary gland is located in a bone cavity. So your pituitary gland is not hanging mid-hair, but it is present in, or it is located in a bone cavity, and that is known as sella turcica. And it is very nearby the hypothalamus, that it is attached by a stalk. So what is a stalk? For example, if I have a flower, so this is a stalk, right? So if I have my hypothalamus here, my pituitary gland is here, so it is very nearby and this is a stalk. Fine. So these are the things I want you to remember introducing pituitary gland to you. So your pituitary gland is the master endocrine gland. Your pituitary gland is known as hypophysis, and it has two parts, anterior and posterior. The anterior pituitary gland is known as adenohypophysis and the posterior one is known as neurohypophysis. Fine. So I guess till this much it's clear. So moving further, so talking about the pituitary gland, the adenohypophysis, that is the anterior portion of the pituitary itself, has two regions. One is pars distalis, the other one is pars intermedia. So the pituitary gland is divided into anterior and posterior region. The anterior region itself is divided into two parts, that is pars distalis and pars intermedia. Fine. So now your pars distalis has anterior, so it is present in the anterior pituitary and it produces 6 hormones. So both are in the anterior part and this produces 6 hormones. So what are the 6 hormones? The first one is the growth hormone, the second one is prolactin, the third one is thyroid stimulating hormone, the fourth one is adrenocorticotropic hormone. So adrenocorticotropic hormone. Fine. So luteinizing hormone, we know this is LH, and follicle stimulating hormone, this is FSH. So totally we have 6 hormones which is produced by pars distalis, the one part of the anterior region of your pituitary gland, right? So let's talk about it. So we are talking about the anterior pituitary. So the anterior pituitary is known as adenohypophysis, right? So this adenohypophysis has two parts. One is pars distalis yes, the other one is pars intermedia. Oh, fine. Yes, this is clear. Pars distalis and pars intermedia. So now this pars distalis produces 6 hormones. So what are the hormones? The first one is the growth hormone. The second one is the prolactin. The third one is thyroid stimulating hormone. The fourth one is adrenocorticotropic hormone. Then you have luteinizing hormone and follicle stimulating hormone. So we have 6 hormones. Your pars intermedia produces only one hormone. So this is known as melanocyte stimulating hormone. So melatonin is different, which is produced by the pineal gland. Melanocyte stimulating hormone is different. So this is commonly known as MSH. Okay. So now we'll talk about each of the pars distalis hormones in detail. So the first one is growth hormone. So GH stands for the growth hormone. So the growth hormone helps in the growth of the body. So that is the function of the growth hormone. But your hormones have to be balanced. Otherwise, you have hormonal problems. So you would have heard from your friends or your relatives or your neighbor that this person has thyroid. So there's a hormonal imbalance. So always there has to be a hormonal balance, and the hormone has to be produced in the amount it is needed. It should not be produced in a little extra amount, neither it should be produced in a little less amount. So it has to be present in the exact amount. Alright? Yes? So the growth hormone, if it's present in higher quantity, if it's more than the quantity that is required, this leads to gigantism. And if it is produced in less quantity, so this can lead to dwarfism. So gigantism when the person is very gigantic, right? These are the two conditions. So sometimes the growth hormone is not balanced in a young adult, so that condition can lead to acromegaly. So acromegaly is when there is an imbalance in the growth hormone in the adult condition, and if not treated, the acromegaly can also lead to the death of the person. So with this, we are done with the growth hormone. So the next thing is we are talking about prolactin. So prolactin in short is written as PRL. So don't get confused if you see a term like this. So it refers to the prolactin. Fine. So the next one is prolactin. So what is the function of prolactin? So prolactin has two functions. So one, it helps in the development of the female mammary glands. One, it develops in the development of the female mammary glands, right? And number two, it helps in the secretion of milk in the mammary glands. So these are the two functions of the prolactin. Clear? So with this, we are done with prolactin as well. So now talking about your TSH. So TSH stands for thyroid stimulating hormone. So TSH. So this stands for thyroid stimulating hormone. So from the name itself or from the term itself, it is clear. So it is going to act on the thyroid gland to stimulate the thyroid hormones. Fine. So we are done with the TSH as well. So now we are going to talk what is ACTH. So what is ACTH? Adrenocorticotropic hormone. So let me write it. Adrenocorticotropic hormone. So this hormone acts on the adrenal gland. So this adrenal gland is present on the anterior region of the kidney. So we have read about the structure of the kidney. So this bean-shaped structure is your kidney. So on the anterior portion, we have the adrenal gland. So this is where your adrenal gland is present. So this adrenal gland has two portions, one is cortex and one is medulla. When it stimulates the cortex region of the adrenal gland to produce its hormone, that is adrenocorticotropic hormone. Fine? Yes? So the last two is LH and FSH. So we know LH and FSH are gonadotropins. So LH and FSH are gonadotropins. So they have different functions in females and different functions in males. Now, how do they function in male? So your LH acts on luteinizing, so it acts on Leydig cells of your testis to produce a particular group of hormone called as testosterone. So now this testosterone plus the FSH helps in the formation of sperms, that is spermatogenesis. Right? So this is how it works in the human male. Now, how does it work in the human female? So the LH hormone helps in the maturation of the ovarian follicles, and your FSH helps in the development so your LH helps in the maturation and your FSH helps in the development of the ovarian follicles. So with this, we have completed all the hormones of the pars distalis. Now, what is the function of the hormone produced by pars intermedium? That is melanocyte stimulating hormone. So pars intermedium, it secretes your melanocyte stimulating hormone, that is MSH. So it also plays a role in pigmentation along with your melatonin. Okay, so that is your melanocyte. So now the next part is we are moving into the posterior pituitary gland. So we are done with the anterior pituitary region. So we are talking about the posterior pituitary gland. So it's known as neurohypophysis. So that is the posterior pituitary, but it's very ironical, I would say. So though pituitary gland is the master endocrine gland, the posterior pituitary does not produce any hormones. Ma'am, something is written. Yes, it's written, but it is not produced by the posterior pituitary gland. The posterior pituitary gland only stores the hormones. The posterior pituitary gland stores two hormones, that is oxytocin, the other one is vasopressin. So these are the two hormones that is stored by the posterior pituitary, but these hormones are produced by the hypothalamus. Clear? So let's go. So the neurohypophysis, it does not produce any hormone. It only stores and releases the stored hormones. So these hormones are vasopressin. So your vasopressin is also known as ADH. So ADH stands for antidiuretic hormone. So this is antidiuretic hormone. Fine. So we have vasopressin, we have antidiuretic hormone. So the next hormone is your oxytocin. So these two hormones are produced by your hypothalamus, but it is stored in your posterior pituitary. So what is the function of ADH or vasopressin? So we have read it in excretory system. So these hormones, when released, have conditional reabsorption. So it ensures there is conditional reabsorption of Na plus and water from the distal convoluted tubule of your renal tubules. That is the function of vasopressin and ADH. So if your vasopressin or ADH is absent, more amount of water is released through your urine and that condition is known as diabetes insipidus. So when more amount of urine is released, more amount of water is released in your urine, so that is because your hormone ADH or vasopressin is not working properly, and that condition is called as diabetes insipidus. Now what is the function of oxytocin? So oxytocin has two functions. It helps in the contraction of the smooth muscles of the uterus. So during the child delivery, and it also helps in the ejection of milk from the mammary glands. So secretion of milk is by prolactin, but ejection of milk is from your oxytocin, right? So you have come from a different name, 𝗣𝘗𝗹𝗶𝗀𝗀. Okay, absorption of water from DCT. Yes, absolutely right. So milk production. Yes, you're right. So is it the same person or the different person? So I guess it should be the same person. So is it you itself, 𝗣𝘗𝗹𝗶𝗀? Alright, so this is about your master endocrine gland, that is your pituitary gland. So now we are going to talk about the thymus gland. So the thymus gland, so where is the thymus exactly located? So your thymus is a lobular structure located between the lungs, behind the sternum. So on the ventral side we have the sternum, so it is just behind the sternum and between the two lungs and on the ventral side of the aorta. So what is the major function of thymus? It helps in the development of the immune system. So if you are able to fight back infections very quickly, if you don't fall sick quickly, so that is because your immune system is strong. So that is because your thymus is functioning well. So it secretes only one hormone, so that hormone is known as thymosin. So thymus secretes only one hormone, and that is thymosin. So thymosin play a major role in the differentiation of T lymphocytes. So they promote the production of antibodies, that is HMI. So thymus is degenerated in older individuals. That's why elderly people have less immunity. So this is exactly where your thymus is present, in between both the lungs and behind the sternum, right? So once again, so you have two, so WBC has a part known as lymphocytes. So these lymphocytes are of two types. So you have T lymphocytes and you have B lymphocytes. So the T lymphocytes origin, proliferation, maturation happens in the thymus. So that is why it is T lymphocyte. And the B lymphocyte is in the bone marrow. But your T lymphocyte stimulates the B lymphocyte to produce antibodies at the time of infection. Since the B lymphocyte produces antibodies and releases into the blood, so this condition is known as HMI. So H stands for humoral mediated immunity. So this is about your thymus. So thymus produces only one hormone, that is thymosin. Alright. So the last hormone that we are going to talk for today, I guess it is the thyroid gland. So after the thyroid gland, I guess we have the functions of thyroid gland and we end the class. Okay. So just to show you that this is the last gland, so don't get saturated. So I know we have spoken about a lot of hormones today. So we are talking about the last gland for today. So that is the thyroid gland. So while explaining the parathyroid gland, I've already told you the thyroid gland is present as two lobes, right? So it's composed of two lobes located on either side of the trachea. So this is the thyroid gland. So here I have my windpipe, that is the trachea, right? So it is interconnected. So the two lobes are not separate, but they are interconnected by a thin flap of connective tissue, and that connective tissue is known as isthmus. Fine. So the thyroid gland is made up of follicles and stromal tissues, that is the inner composition of your thyroid gland. So each thyroid follicle has follicular cells which encloses a cavity. So this is the design of your thyroid gland. So once again, your thyroid gland is composed as lobes, right? And both the lobes, so in between the lobes you have the trachea, that is the windpipe, and both the lobes are connected by a thin flap of connective tissue. So that is known as your isthmus. Okay. So the thyroid gland is composed of follicles and stromal tissues. So each thyroid follicle has follicular cells which encloses a particular cavity. So your thyroid gland produces two hormones. The first one is tetraiodothyronin. So tetraiodothyronin, which is also known as thyroxine. The other one is triiodothyronin. So tetraiodothyronin and triiodothyronin. So tetra is 4, so this is T4 hormone. So tri is 3, so this is T3. But thyroxine is referred to for T4 hormone. So these are the two hormones of your thyroid gland. Fine. So moving further. So iodine is essential for the synthesis of the thyroid gland. So when you do not have enough iodine, your thyroid hormone secretion is deteriorated. So it is either increased or either decreased. So you have to have normal iodine in your blood. That is the reason we also take some salt, right? So we say iodized salt. So deficiency of thyroid, so when you have less amount of thyroid hormones, so that condition is known as hypothyroidism. So hypo is less, hyper is more. So hypothyroidism, so less thyroid hormones. So this leads to the enlargement of the gland. So sometimes it can lead to goiter. Right? So sometimes in case of your hypothyroidism, so you also have a condition known as cretinism. So in case of hypothyroidism, so you have cases called as cretinism. When the pregnant mother has hypothyroidism and she is pregnant, so that condition is cretinism because it can affect the baby. So the baby tends to have low IQ. So, and they have irregular menstrual cycle. This is hypothyroidism. So sometimes hypothyroidism normally can also lead to Hashimoto's disease. Hashimoto's disease. So this is also due to hypothyroidism. right? But when you have increased production of thyroid hormone, so the people tend to put on a large number of weight, so a lot of weight, because the metabolism is too high. Sometimes it can lead to cancer or development of nodules, extra structures in the thyroid gland due to increased secretion. So this increased secretion is known as hyperthyroidism. Fine. So exophthalmic goiter is a condition which is because of increased production of thyroid hormones, that is hyperthyroidism. So enlargement of the thyroid gland happens, you have protrusion of the person's eyeball, you have increased BMR, that is the basal metabolic rate, weight loss is there, and this leads to Graves' disease. So it is a condition, and this condition can lead to this kind of disease. So in this chapter, which has high weightage in human physiology, yes, you have to remember the diseases which is caused by hypo or hyper secretion of a particular hormone by a particular gland, right? Clear? So this is about your thyroid gland. So what are the functions of your thyroid gland? So it regulates your BMR, so your body weight and your metabolic rate, it has to match, so that is your BMR. It supports the process of your RBC formation. So when you have less amount of thyroid gland, so your RBC is also not properly formed, so thus you tend to become anemic, right? So control of metabolism of carbohydrates, proteins and fats. So when you eat something, so it depends on your metabolism. So if your metabolism is very good, so it's properly digested, right? So if not, you tend to accumulate a lot of fat. So it controls the metabolism of carbohydrates, proteins and fats. So maintenance of water and electrolyte balance, it checks that your body is not dehydrated, it is not extremely running out of iron, and everything is maintained in a proper balance. So thyroid gland also secretes another hormone. So long we only thought thyroid gland produces two hormones, that is T3 and T4. But now to our surprise, it also produces a third hormone, so that is known as thyrocalcitonin. So this is the third hormone. So this regulates the blood calcium levels. Ma'am, we also spoke about parathyroid hormone, which also regulates blood calcium levels, and thyrocalcitonin also regulates blood calcium levels. Yes, but pay attention. When your blood calcium level is very high, okay, so then the thyroid releases calcitonin and your blood calcium level decreases, because we need the production of calcium in a particular level. We do not need high circulating calcium levels, neither we need low circulating calcium levels. We need the exact level. So when your calcium level in the blood is too high, then the thyroid gland produces calcitonin, which brings it to the normal level. When your calcium concentration falls below the normal, there comes your parathyroid hormone. So your parathyroid hormone and your thyrocalcitonin work or have opposite function. Your parathyroid hormone increases calcium level, whereas the thyrocalcitonin decreases calcium level. So they both work in the opposite direction to maintain equilibrium in your body. So this equilibrium is called as homeostasis. Fine. So today we spoke about pituitary gland, the master endocrine gland. Then we spoke about the thymus gland, then we spoke about the thyroid gland. So we are done with the 6 endocrine glands, we just have the remaining 3. So we have your adrenal gland, so we have your pancreas, then we have your gonads. So we just have 3, and then we'll also talk about the mechanism of hormone action, because that is in continuation with all of these. So probably we'll be done with the chapter tomorrow. So Vedak, hello, hi, so thank you so much for joining us today, but I guess you're towards the end of the session, but don't worry, so please do watch the recorded lecture. So I guess yesterday they have uploaded a video, so I have done a video on how anesthesia actually works on your brain. So it's a 3-minute video, so I would request all of you to watch that to understand how anesthesia actually works and to which date it dates back to and how old anesthesia term is. So it is nothing new, it's been there for decades, so you can just go through the video. It's just a 3-minute video. Alright, yes, so please do like my channel for more such interesting videos, and please do like, share and subscribe with your friends if you genuinely like my way of teaching. So once again, a gentle reminder of the Pathfinder course, so please join me in this course. So the entire package is 35,000, but you get an off of 3,500, that is 10% if you use my coupon code KR10. So the course is already begun on 15th of November, but you get unlimited access to the class lectures. So please be there tomorrow, so don't delay any further. So we are talking about biological classification and I am handling biology there. So you get physics, chemistry as well as biology. So please don't think, so come quickly join us. Alright, so please do like, share and subscribe, and please take care of yourself. So tomorrow we meet. So until then, so tomorrow at 5:15, so we are going to talk about the remaining 3 glands, and we are also going to talk about the mechanism of hormone action. So until then, this is me signing off. So take care and bye.